Coming up this week on Let's Make It, Bob is back and we're going to talk about relays and Arduinos again. Coming up right after this. Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello and welcome to another episode of Let's Make It. This is episode 21 and we're recording this on the 21st of May. And it's 9 p.m. And I just want to let you know, next week we're going to start recording this show starting on Mondays at 9 p.m. So this is the last night we'll do this on a Tuesday night. And I have a special guest with me tonight. I have Mr. Bob Powell. Say hi, Bob.
Hello.
And tonight we're going to talk about relays. Actually, Bob's going to do most of the talking tonight. He did almost all the work on this show. And I'm just going to get him started and let him run on. He's done a lot of cool things on his side. And he's going to show you how you can use relays and relay boards to control things with an Arduino. And our first thing we're going to do is show you an Arduino blinking a light. And I think, according to Bob's notes here, he used the standard blink sketch that came with the Arduino to do this.
Yes, that's right. All right, well, let me switch to this. So here we have an Arduino, and it's preloaded with the blink sketch. And so because of that sketch, we have one wire connected to pin 13, which is the standard LED pin for an Arduino, and then this is connected to ground. And then these two wires are connected in line to a lamp, well, through an extension cord to a lamp, and this is the base of the lamp right here. And I can't get the camera and the lamp and the Arduino all together, but it is all wired up, and you can see that I have the little alligator clips, and then I have a very unsafe extension cord connected here, but it is all connected. And it's a general purpose 5-volt relay, and with the standard sketch, and here we are, we're going to power it up, and it'll flash when we start, and it works.
So we should say don't try that at home with this electrical wiring. This is just for demonstration purposes.
This is all for demonstration. No, we would never do this. And in fact, if there were any kids around, I wouldn't do this either with exposed electrical lines. But with just me, hopefully I can be safe and not electrocute myself. So
one of the things we do want to make sure we cover, the relay itself is 5 volts. So the Arduino is powering the actual action of the relay.
Yes.
And the relay, what's the relay rated as far as the load it can go through it?
This is a 5-volt, 3-amp relay. It's a general purpose relay, and I think we have the data sheet in the show notes.
Right, that'll be in the show notes. Yep.
And now we are at the limit of what an Arduino can do. This particular relay needs 450 milliamps to operate. To grab the coil so the circuit is made. So it's right at the limit, but it works perfectly well on an Arduino, and it's very easy. And it's actually when I was putting this together, every step of the way you test what you're doing, and I actually had it set to an LED, and the relay worked on an LED just as well as it does a lamp. So a relay is very easy to work with and easy to program.
Okay,
since we are using we're using the basic sketch, the simple blink sketch from the Arduino library.
Right. I was going to say, do we want to walk through that little sketch real quick to show how simple
Sure.
it really is?
Sure.
Let me see where I have it here. Oh, yep, I do have it right here. So, really, it's what, maybe of actual code to a dozen lines or so.
Yeah,
So
that's about right.
you're basically setting up the pin as output LED pin, which you defined at the top as 13, and every 1 second you're just toggling low to high.
That's right.
Can't get much simpler than that.
No, not really. So very easy, very simple. So and that's the nice thing about relays is and there's a multitude of relays out there.
Right. All kinds of different choices. In fact, I've been playing with one with the Raspberry Pi. I'm going to talk about that in a little bit here. Another project I've been working on. Can give a little update on it. So the other thing is on the show notes, you have all the links. There's a link here to Wikipedia. Actually explains what a relay is right here.
Yes.
And that'll be in the show notes as well. It's actually an interesting read. Gives you a little bit of a history and stuff like that as well. And there's also the link to the actual relay he used, so the link to Mauser, so you can actually get it, and the data sheet as well. And that
it's an inexpensive. Yeah, this was a general purpose relay, very inexpensive. So it's a nice little, it's a nice relay to have around for playing and testing and.
Right. For $1.50 you can't go wrong with something like that. Either.
Yeah. $1.50, $1.55, something like that.
$1.53, I think, is what it says.
So yeah, it very inexpensive.
Okay, so that was a very quick walkthrough of the first thing that we were going to talk about tonight, and you can see it's already loading up for the second one. Before I get there, I do want to thank our sponsor, Ting. Ting is sponsoring us at least to the end of May. And Ting, if you've never heard of it, is an MVNA. It's basically a cell phone company without the cell phone hardware. What they do is they lease from Sprint all of the towers and everything, so they can focus on the customer service and the support of their service versus worrying about all the hardware and all that stuff. So they basically buy back, and because of that, they provide you excellent customer service. Ting is owned and run by Two Cows, and if you've ever heard of Hover.com, well known for their outstanding service, in fact, never putting you on hold, things like that. And Ting is following along with that, and they have great rates. I'm going to show you, go through the rate plan real quick. There's no overage penalties. In fact, they give you back money if you go under. They give you back credit on your late months. You put multiple devices, so you've heard of the family share plan. This is what they are. They're a family share type of plan, like the Verizon and the other carriers are now starting to follow along with. It's great pricing for small businesses, very easy to share minutes between the phones. There's no overage fee. So if you go over your minutes, they basically bump you up to the next level. They don't charge you a fine, so you don't have to worry about where you are every month. And tons of free features, and the two that get me here that are free are tethering and hotspotting. That's typically not a free thing with any of the carriers. So that's all included. No contracts. You can come and go as you please. You can add a phone this month and 2 months, take it back off, or whatever. There is no contract. And you can bring your own device. If you already have a phone on Sprint, it'll work just fine with Ting. And as I mentioned, their support is geek powered. They are and they are empowered, I should say, as well. When you call them, you will not be put on hold. So they will answer your phone call. A human will answer your phone call and never put you on hold. And they can take care of your problem. There's no transferring you to their supervisor. They are empowered to take control, and they know the products very, very well. And you will see when we go through the hardware real quick, they have tons and tons of Android devices. The bills are very easy to read and cool graphs that show you how you're using all your time and your minutes and your data and stuff like that. So let's come back up here, and like I said, the devices, we're going to go through these really quick. Tons of Androids. You'll find in here that you have the new Galaxy S4s in here already, the Galaxy S3 right there. You can get the Samsung Galaxy Nexus. Here's the HTC One, the new HTC One that everybody's really talking up. So tons of choices out here, and you own the phone. There's no monthly fee for the phone, no contract. They do have some lower end feature phones and also some home solutions for if you want to use your home phone as over your Sprint network, and the personal cell tower if you have bad coverage in your area. Now, the cool thing about Ting is right here. It's the plans. You can come in here and let's say you have a family of 3, so you have 3 phones. Each phone is only $6 a month. So we have 3 phones, so that's $18. And for 500 minutes is $9. For 4,000 texts, must be kids in the family in this example, it's $11, and a gigabyte of data is $24. So that adds up to be, for a family of 3, $62 for 500 minutes, a gigabyte of data, and 4,000 text. And you can see if you don't do texting, you only use data, you just dropped off $11, you're down $51. That's a great price. And we definitely appreciate Ting sponsoring Let's Make It.
Hi, everybody. I want to break in here 1 minute after the show was over. Bob and I were talking, and we wanted to know if we were hitting the mark as far as what we're teaching you about electronics. So we need to know, do we need to go more into detail about the electronics part versus the Arduino coding part of it? Like, do you need to know how resistor works, capacitor? Do we need to teach you about like a difference between an NPN and a PNP transistor? So we've been kind of going at a higher level and assuming you knew some of that, but maybe we shouldn't be assuming that. So what we need your help is, you tell us if we need to go more in depth with the actual electronic part, like understanding, like Bob said in tonight's show, he put 3 resistors in a row to equal up to be 900 ohms. And he put 3 300s in line, something like that. I can't remember exactly what the value was, but versus putting them in parallel, which wouldn't do that. So that's the kind of thing we need to kind of know is, like, do you need more basic electronic knowledge, or are you fine with us just talking at a high level about electronics? I mean, we're kind of assuming you understand. Like tonight, he used a voltage regulator, which we didn't really describe in great detail what a voltage regulator was. He did describe it some in his drawing and everything, but do we need to go into more detail like that? And we just need to make sure we're giving you what you need and not sticking at a high level, because some of the projects coming up are going to start using more electronics in them to do some of the tasks. One of the shows coming up either next week or the week after is probably going to have a number of transistors in it, and we were talking about using a transistor array. So do we need to go into explain how a transistor works and the values and things like that? That's what we need to know. We need to know that so that we can put the right detail in the show that you need to understand what we're talking about. We don't want to talk over your head. That's not the whole goal of this is to teach and to learn and have fun together. But we want to make sure that we're going to the low enough level so that if you're just getting into electronics, we are giving you the basics that you need, like how to use a resistor, how to use a capacitor, things like that. What do they do? Or are we at the right level just sticking with the Arduino and the code? The whole concept of the show is to make something, but we're not saying we need to, we assume you have a certain level. I've always just done basic. Well, what we've been doing so far is pretty basic, not many parts, occasional resistor so you don't blow out the LED, things like that. Do we need explaining why we do that? Is another question. Why do we got to put a resistor in line not to blow out the LED? Considering the resistor, the LED typically is a 5-volt LED, things like that. So, do we need to describe the difference between the Ohm's law, or what's the difference between voltage and amperage, things like that? Do we need to go to that level and take a week or two maybe and just do the basics, and then as we get into more of the electronic parts, describe how they function? Or are you fine with us going and just assuming you know that stuff? So we don't want to just assume it. We want to make sure that we cover as much detail as you need to understand how things are working. So we would appreciate if you just send us an email let's make it at techzen.tv and give us your opinion as far as where we're hitting the mark as far as teaching you the electronics part of it versus just the programming and the Arduino part of it, and where do we need to go, because we're going to start getting into more projects that are much more complicated and require more electronic knowledge, and we'll try to explain that as we go through it, but we want to make sure we cover the basics as well. And one way we would do that is when we get into a show that has a new part we haven't used before, we would probably set aside a little segment just to show you how the part works and explain its theory. And we wouldn't give you like a whole show of just electronics theory. We would when we get to a new part, we would just go into more detail, or do we not need to go into detail? So it's really up to you, our audience, because this show is for you. I mean, yes, we have that passion for this, and we'd love to do it, and I would do it even if it didn't have a show. I did, and I have been for a long time. So this really is something we want to make sure we do what you like us to do, and we'll definitely appreciate your feedback on that. All right, back to the show. And okay, so Bob, before I get on to the next segment, I want to talk about a project that I've been working on. Kind of goes along with the relay thing. I don't know if you remember any of the shows I talked about building an on-air light. And I have the on-air light, and here's the actual light itself. And inside of this,
yes, I do remember that episode. It's been a little while, but yes, I do remember that episode.
I've been. This is actually a bought light, but what I've done, I'm also making one. It's a wood box versus the metal box, but I have a Raspberry Pi, and it has code running on it. Actually, I can show you what it looks like. Let's see. 121. So I can go over here, and this is software that's actually running on the Raspberry Pi, and you can see it's monitoring my Ustream and my Justin TV streams. They're the only two that I can really monitor of my 4 streams. But it tells you how many viewers are on, and it goes down through and it shows you history up to the last year. And you can see right here it's the green Ustream and green Justin TV, which means my stream is up to both of those. And if I have it set up in settings where, I can monitor different channel statuses, and based on that, I can say the light comes on when either all feeds are up or on any feeds up. I can configure how I want the light to work. So what it does is it constantly is monitoring my streams, and that controls a relay, which we're talking about tonight. That's why it's kind of relevant. That controls on the back of this box. Let me go back to the box. You can see this little LED strip back here. So it's a 12-volt LED strip, and that turns on and off based on the relay. The relay that's up here, and that connects to the Raspberry Pi. So that's just a little bit of an update on a project I've been playing with and trying to get to work. So now let's go back to the next relay project Bob has, and you can kind of see it there in the back. Let me just get it a little closer. Go for it.
Okay, so we'll walk through the components. So we've got the Arduino Uno hiding back there in the background, and then it's kind of back here in the back. This is a 595 shift register that we talked about a few weeks ago, and I've got it connected to this SaneSmart 8-channel relay board, which is I've actually been real happy with this board, although the documentation that came from SaneSmart is lacking.
I've had that before with other products from them as well. Yeah.
SaneSmart, if you're listening, we can help you with that. Contact me. And then in front right here is an LM317 setup. And the reason that I did that is because this board is going to draw more current than what is available with the Arduino. So I've configured this to supply a 5-volt supply, and actually, if you look, the Arduino is not connected to anything. And when we actually fire this up, I'm going to use this connector, and I'm going to power the Arduino from the 317. So, and I think you've got the diagram for a 317. So this is the typical setup, and in my case, it's normal for a 317 to use anywhere from 200 to 500 ohm R1 resistor. In my case, I'm using a single 300 in the R1 position, and then I'm using 300 ohm in series to make 900 for my R2 position, which gives me 5 volts. And when I was setting this up, I, of course, checked this before I powered anything, and my multimeter told me I was getting 5.02 volts. So I'm getting a nice supply, and I do have two 0.1 microfarad capacitors in the setup to clean up the power supply a little bit. But the setup is exactly the way this diagram is, and I think we also have in the show notes you'll have a link to the specific 317 that I have.
Yeah, I do. Hang on, let me get that up here. Somewhere I have it. Oh, there it was. That's what you're looking for right there?
So this is the 317 specifically that we're using, and it'll supply. Oh, I just.
You want to go back to the other drawing?
It'll supply 1.5 amps.
Oh, okay. 1.5 amps.
I don't remember.
Yeah, right here, 1.5.
Okay, so it'll supply 1.5 amps. So, which is more than enough to supply this setup. So, but this is a very typical 317 setup. And the other thing about a 317, if someone wants to, they can also use this. We don't have it in the show notes or diagram here, but you can also use it to limit current. And in this case, I've got a 12-volt power supply that I'm plugging in, which will deliver the 5 volts to this entire setup. And the relay board uses 5 volts. The Arduino's on 5 volts. Shift register's on 5 volts. So it all works out very nicely with all the components.
Yeah, I think what's maybe important to help them understand is that everything's still 5 volts. It just you needed more current to run the relays than what the Arduino could put out.
That's right. The Arduino, the 450 milliamps is what it's pretty much limited to. And when you're driving all of these relays, you're going to draw much more current than what the Uno can supply.
Did you know what the current is for those?
It's, I think when everything's on, it's a little over an amp.
Okay. So you're getting close with that 1.5 amp then.
Yeah, I'm getting close. Yeah, we're getting close. But when you're, it's been a little while since I read I knew that 1.5 was going to be fine. So, and this, the other thing to remember about a 317 is that it does get hot. In this case, it's bleeding off. It bleeds off extra voltage as heat. So. If this runs for very long, it's actually hot enough where I can't touch it.
Yeah.
So,
yeah. Always be very careful pulling these out.
Yeah. The other, I guess it's a little, it's a place where you have to be careful, and Arduino it warns you not to do it, is that I am powering the Arduino from the 5-volt in pin. Which in this configuration is not regulated. Where
right, so
if
it's not recommended because there's no protection for it.
There's no protection. So that's why testing with the multimeter ahead of time was absolutely critical.
Right, because it would not take much for you to blow that.
That's right. Yeah, blow it up quickly.
Right.
And of course the code, since I don't have it connected to the USB, because as soon as I plug it in, it's going to try to run. This is the same code that we looked at a few weeks ago when we were talking about shift registers, and the only thing that I changed was the number of LEDs, which is the way I named it in the code. Has been changed to 8, and the number of registers is back to 1, since that's all we have here. And of course, in this demo, I only have one of the relays connected to the lamp. I don't have 8 lamps.
Right.
My desk isn't big enough for 8
But
lamps.
if I remember correctly, that relay board has lights on it, correct? So you can kind of tell the
Yes.
status?
Yes.
And, if I remember correctly, the lights are backward what you would think. So when the lights are on, the relay is really off.
That's right. So, and I'm going to plug in the lamp right now. And there is no power to this, which is actually one thing if I had a criticism for this relay, it would be that just for safety, I would prefer the relay to be off when it's not powered. But in this case, it's actually connected. The circuit is made and the lamp is now on. But as soon as I plug this guy in, you can see the lamp is turning on and off. And it is this, it's this first relay that I've got it connected to. But this is the same code that we used, and it is fast enough. Those blinks that we just went through are timed at 50 milliseconds, and the relay board and the lamp can actually go that fast, which
Wow.
I was pleasantly surprised by. And of course, that's so. Here, I unplugged the lamp and just left the relay board.
Yeah, I think you can get the idea from that.
Yeah, I think we. But this is the same code that we played with a few weeks ago.
Right, I saw the code was the same. I'll stick it in the show notes again, so I have to go searching for the other show. But yeah,
And I'm gonna unplug this.
yeah,
So
yeah, you can definitely hear it working too. You hear everything clicking.
Yeah.
So I think it's one of the things that's maybe a little important that we talk about here also is you're not actually connecting to the relay coil directly in this situation, right? You're going through it's either an opto isolator or what? Do you know what it is? Did you look see what it was?
I haven't looked.
Yeah, so it's it's some kind of H bridge. You know, it's either opto isolator or a transistor of some kind. You know, so that you're not taking the power from the Arduino itself to power the relay coil.
I'm guessing given the way this acts, it's probably a PNP transistor.
Okay.
But to be honest, I haven't looked yet. But it isn't, for what I'm doing here, it wasn't important for me to know.
No, it's not necessarily relevant. Just want to make sure that they understood that we're not actually powering the coil itself.
That's right.
Through the Arduino.
Yeah, and now that
unlike the first one you did, that's why I was trying to make the difference between them.
And now that I've got this unplugged, we can see the setup. Here, these are the 8 lines for the 8 channels. This one right here is VCC. This other one is ground. And then, of course, from the Arduino, we're just using 3 lines to run the shift register. So it's very easy that's one thing I really liked about this SaneSmart board is that it's very easy to connect and very easy to use.
I have other SaneSmart products as well, and I like their stuff. It just the documentation leaves a lot to be desired.
Indeed, it does.
But they weren't the only ones like that when it comes to this kind of stuff either, because other manufacturers are the same way.
That's true. But relays are really easy to use.
The other thing about relays, it allows you to control things with a much larger power. Like you're controlling a desk lamp, it's 110 volts AC, and you can control that,
That's right. And most of these, even the relay that was in the the single relay in the first demo, it'll actually run 240 volts.
Do you know what rating though?
If I remember right, it's just 3 amps.
Yeah, it's not a lot, but that's more than enough for a light bulb. Way
more than enough for a light bulb,
right.
and of course, for what for what we're doing, that's perfect. But there's plenty of other relays out there that that will supply, tens of amps.
Right. They typically don't run off 5 volts though. It's typically up to 12 volts or something like that would control those.
Typically, no. But then, if you were going to do that with an Arduino, now you'd put in a transistor that
Right,
would
exactly.
power the relay, and you end up doing the same thing that we've just
Right.
shown.
Right,
So,
exactly. So have you ever played with any relays that aren't really physical relays, that are more logic relays? I mean, I know they can't put as much power through them, but there's no physical movement of it. I'm trying to think of the one I used to have
the
a
solids, yeah,
solid state.
I've played with solid state relays before. They're nice. They're quiet. They don't have, most of them don't have a high current rating.
Right. That's the bad thing about them. Yeah.
Which is a bad thing about them, but they are quiet. Where this board was, you could hear it clicking in the background.
Right. I mean, I've used them before in a situation where I was doing some DMX control of contact closure type things, and they worked fine for that, like putting up and down projector screens and stuff through DMX. So
yeah, that's right.
But they're real low voltage, like 12 volts. It's a contact closure type of thing, so they were good for that. Good for that kind of stuff.
But pretty much any application, there's a relay out there,
Right.
and with a transistor or two, you can get an Arduino to run pretty much anything you want.
Right. Anything else you want to show them relay wise tonight?
I think that's about it. We've talked about 317, the preloaded code, easy relays are. Have we missed anything?
I don't think so. Let me ask you a question. I know for
Sure.
next week's show, we were talking about doing the 7-segment displays. Are you up for that? Did you get that?
Oh, yeah.
Did you get that chip?
I have not gotten the chip that we mentioned, but I've actually got a single 7-segment display ready to go.
Okay.
And on one of my boards, I even have a 14-segment display.
Okay.
Which
Great.
we may.
Right. I have the other chip. I haven't really had a chance to get it all working, but it's put together. I just haven't had a chance to test it all out yet. But we can maybe mix our stuff together. So that's next week's show.
That's next week's show.
Right.
Well, the chip won't be a problem because I'm fortunate that I live just a few miles away from Mauser's warehouse. So
Yeah, actually, I wish I had
I
something like that
can
around
get-
here. There's not in this area that I know of. There's no electronics store that carries parts like that. I just can't drive somewhere and get it that I'm aware of.
Well, I'm
That'd be dangerous if that
fortunate
was the
that
case.
there's yeah. Well, there's a couple places nearby that
Well, yeah,
that I
know
can
down
get
in your
parts.
area. And there may be something in DC or Baltimore area, but I'm not aware of them. I would drive that far. I mean, I drive almost to DC, a couple times a week anyway, so it wouldn't be a big deal to go a little farther and get something. Give me a reason to go down that way a little more. But
That's right.
All right. Well, for show notes from this show and all Bob's code and links to everything, if you go to techzen.tv and click on Let's Make It, you'll get show notes for today's show, and you can watch all of the other shows as well. We'd love to hear from our viewers and get your feedback on stuff. It's how we kind of go forward. In fact, we've been getting a lot more feedback. I sent an email to Bob today about a question about 2-wire interfaces, so we're going to try to work up something with that in here soon as well. So
That should be fun.
Yeah, that should be fun. We've done 2-wire interfaces with the LCD before, but we haven't done it with the way they're asking us to use it is like using a keypad input, like reading keypad input, which is very interesting. I've never seen it done that way before, but I think that'd be a really neat thing to try to tackle. So we're going to start working on that. But if you have ideas, definitely email us at letsmakeit@techzen.tv, or you can go to the show page and there's links to all kinds of ways you can contact us socially, social media, Facebook, whatever. Or you can leave us a voicemail at 913-732-3327. And that's just a Google voice, so there's nobody going to answer the phone, so don't be scared. Just leave us a voicemail and we'll get that and we'll listen to it. And if it gets playback on the show, don't be scared. But sometimes that could happen as well. You can also, if you made something really cool and you want to show us what you made with an Arduino or a Raspberry Pi or whatever, make a video of it, upload it to YouTube
or Vimeo or something like that, send us a link, and we may see that on the show very soon as well. And I want to thank Bob for being with me again tonight.
Thanks for having me on.
Yeah, it's nice having somebody to talk to. Okay, so I think that's it for this week. Like I said, next week we're going to try to do 7-segment displays and drivers. So check back in again next Monday at 9 p.m. Not Tuesday, next Monday at 9 p.m. And we'll see you all next week.
Good night.
See ya. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.